Hey folks, thank you very much for joining us today. We're going to be talking about building automated validation of your cloud security controls. And thank you again, Lydia, for the amazing segue. Lots of topics there that we're excited to go a little bit more into detail on. Before we get started, my name is David. I work on the infrastructure security team at Roblox.
And I'm Georgios. I work on the detection and response side.
So we're going to dive right into it by walking you through a sample scenario to kind of highlight some gaps that you might have in your security controls and why it's important to validate them, and then how you can go and implement some of these solutions. So let's take a sample scenario where you join an organization as a cloud security engineer, and your job is to roll out an initial cloud security baseline that fits for your organization. So it's going to vary a lot, depending on your organization's needs and posture, but we're going to keep it pretty simple for this example. So you're going to focus on two things. The first control we're going to build is a preventive control, saying that publicly exposed compute without prior review is not allowed. Seems like a good idea. The second one is going to be a detective control. Well, let's say that we have a number of really important data stores that we have in our business, and we want to know about configuration changes to them. So we're going to implement a detective control to make sure intentional or malicious changes to these data stores are something that we know about and something that we can alert on. So let's take a look at what an example of the first control might look like. If you're familiar with AWS, this is an IAM policy. The semantics don't really matter too much. We're going to focus more on the intent here. So we have an API call called EC2 run instances. This is essentially what you're going to call if you want to spin up a virtual machine, an EC2 virtual machine. And what we're saying here is that there's a condition that you can pass in that API call, where you can request that your virtual machine is going to have an IP address associated with it. If we see this kind of coming in an API call, we're going to deny that API call and say, hey, this is not allowed because you're creating compute. You're attempting to associate a public IP address with it. This is in violation of our security baseline, and your call is going to be denied. So we take a look at this. We submit it for a pull request. We do a manual review. We test it out locally a little bit. Things look pretty great. We just got here. We're in our first 90 days. We're delivering impact already. We're feeling good about ourselves. Let's take a look at the second one, which is detecting a configuration change to a data store. So for example, you have a really important bucket that you call my important bucket. And this bucket has all the business critical data or PII or whatever is really important to your business to kind of handle. And what we're going to do here is we're going to say, we want to monitor changes to the lifecycle configuration of this data store, of this S3 bucket. And what a lifecycle configuration is, if you're not familiar, it's essentially a retention policy for your S3 buckets. So you can use this for cost purposes. So if you want to transition data from a super active or a super warm tier to a colder data tier, it's a great cost savings tool. And it's also great for data hygiene. You can say things like, hey, after 7 days, I don't care about this data anymore, expire it all. Great for cost and then great for security if you don't want to hold on to extra data that you don't need. So we want to keep tabs on this because if somebody can accidentally write a lifecycle configuration that expires all of your critical data in 1 day, and then you don't have a business anymore. And that could be an accident or it could be intentional from a malicious perspective. So we just want to keep tabs on that. So we write this detection. We're looking at the CloudTrail data source, which is AWS's audit logging plane. Whatever SIM of choice, whatever detection engine you use, it doesn't matter. You're parsing the same JSON. And so we roll this out as well. We test it. We do a pull request, we go through the whole process, things look great. So a couple weeks later, we're poking around in our AWS environment and we're noticing that there are still virtual machines being created that are publicly exposed to the world. There's still EC2s with public IPs everywhere. Nothing has changed to our deployment patterns. We kind of rolled out this control without we were preventing isn't being prevented at all. So what happened here? If we take a look at this condition in the IAM policy that's written here, you'll see the parameter that I talked about, which is the associate public IP address flag. Now, this flag is not present in every single API call. I think Lydia alluded to the different kind of mechanisms and different APIs and all their nuances. So this parameter is an optional parameter. It's actually not enforced. And so what happens is if this Boolean condition is not here, your condition is not going to report as true, and your control is going to allow an EC2 to be created. You might be asking, okay, who cares? The EC2 machine is not asking for a public IP address. What's the point here? And I got a little ahead of myself. The only situation where this API parameter is going to be present 100% of the time is if you create a virtual machine through the console. So if you're creating stuff through the console, which hopefully you aren't doing, but in some environments it happens, this control is gonna work great. If you're using anything else like Terraform, the AWS CLI, other abstractions via API calls, as I mentioned, this parameter is completely optional. And what happens here is there's a little decision tree. So starting off on the left side, if this parameter is set, our security controls apply. We all agree, we tested it, life's good. If not, and this parameter isn't set, whether your EC2 instance gets a public IP or not is going to be determined entirely by your networking configuration. So if your subnet has a setting that has auto-assign public IP to be enabled, your EC2 is going to get a public IP, your control is going to fail even though you thought it was working. And this is actually how the default VPCs work inside of AWS. When you create a default VPC, or it's actually created for you when you spin up an account, you have public subnets in there with that auto-assigned public IP enabled to true. So this is a very real scenario that could be happening in your environment. Let's take a look at the second one. This one might be a little bit more cut and dry, right? We took a look at the API documentation. We're looking for the lifecycle configuration change. And I have a screenshot from the permissions page here, just explaining again what it does. And we tested it, we created an S3 bucket, we modified the lifecycle configuration, our detection fired. What could be the problem here? As Lydia also mentioned, APIs change all the time. Here's a screenshot of the documentation. Might be a little bit hard to see, but in that red box it says, for an updated version of this API, which is the put bucket lifecycle API, you want to use the put bucket lifecycle configuration API. So same API, just the word configuration got added to the end of it. And this previous version has been deprecated, but is still supported for pre-existing infrastructure. So you can imagine a situation where you're getting dropped into an environment, your business critical data is probably some of the older data in your environment. Maybe there's some S3 buckets that are many years old. And if you change the lifecycle configuration of an older S3 bucket configured with a put bucket lifecycle rule, what our detection is looking for is an entirely different API. It's not going to show up. So again, you're going to find yourself in a scenario where you think you're covered with the detective control, but you're actually missing for maybe some of the most critical data stores in your environment. So there's this really nice website called permissions.cloud, which will redirect you to aws.permissions.cloud, and it has all the API methods and permissions being tracked for the 3 major cloud providers. At the time of putting these slides together, there's over 15,000 API methods and 17,000 permissions in AWS. And of course, new services and APIs are released all the time. So this number is pretty much just only going to increase. So we looked at 2 specific examples on one API for an S3 bucket and one API for an EC2, but there's hundreds of different services and namespaces out there. So at this kind of scale, what can we do to build our cloud security baseline, but not just build it, also prove that it's working? Because we want to find out that it's not working from one of our tests and not from an incident, whether it's operational or some kind of breach. We're going to do a very short concepts refresher, just so if you're not familiar, you can kind of understand what we're referring to. So AWS has a concept of organizations. Every cloud provider has something similar. Essentially lets you group your accounts, your projects, your subscriptions into different subunits, and you can manage them accordingly. The important thing about organizations in AWS is it lets you administer centralized security policies through a service called the service control policy. And this is the first preventive control that we're going to be discussing today. The second preventive control which you might be using is something called a resource policy, and AWS continually expands the support for resource policies. Earlier this year, they added support for DynamoDB. And this differs from a service control policy because it's not centralized, it's attached to a specific resource. For example, an S3 bucket at DynamoDB table, you go one by one here. So let's take a look at how we can validate some of these controls, and we're going to start off with validating service control policies. So what we kind of want to do is we want to create an environment where we can test out these controls and function exactly as we would in a production environment without worrying about breaking anything. So what we do is we create, we call it a sandbox AWS account. So there's no other workloads, infrastructure, identities in there outside of what we need to support our testing framework. It's a part of our organization, so the same security controls, the same service control policies apply as they would in test, staging, and production. And what we have is something very basic. Our goal was to build something where we'd have to set it up once, never touch it again. So we use Lambda, which is serverless, very easy to set up. We have a cron job running on Amazon EventBridge, and we have a CloudWatch alarm monitoring the Lambda for application failure. So if you have an IAM permissions issue, you push some bad code, et cetera, and your Lambda is not running at all, which means it's not validating your security controls, we're going to know about that too. So what is your Lambda doing? Or what is our Lambda doing? Our Lambda is parsing a YAML file which has test case definitions. And I'll show you an example of what that looks like in a second. But what we're doing is we're going to take all of our security controls, convert them into test cases, and then we're going to check two things. One, is this action allowed? Two, is this action denied? And then I'm adding a third, is there any drift between what we expect and what the Lambda is doing? And so this runs on a cron job. We have any drift, any difference from the expected output in the test and what the Lambda sees, we immediately fire an alert. And this gives us that continuous validation. So we know if there's drift, whether it's a new API call that got pushed, or we pushed a new service control policy and there's a regression compared to something else we were testing for. It gives you that continuous validation for your preventive controls in your baseline. To give you an example of what some of this might look like, I'm going to focus on the second box here. These are just screenshots of individual tests. One thing you might want to do is ensure that nobody can disable your CloudTrail logging. And CloudTrail is audit logs for AWS. If you want to do any kind of threat detection or monitoring, this is your primary data source. So we want to make sure that nobody can stop logging, and there's a number of other things that you're going to want to check for here, but we're going to keep it pretty basic. And the expected result here is deny. So if any identity wants to stop logging, that action should always be denied. And what we do also with our Lambda is, because it's in a sandbox environment, we give it full admin privileges. And this is great because it lets you simulate two things. One is if you try to right size your permissions on the identity perspective and you try checking for access denieds, you're going to get a lot of differing responses from different services. For example, if you try to do things with an S3 bucket and you limit your permissions, you're going to get different responses from the S3 client based on what kind of permissions you have or you don't have. Now your application code is going to have to handle a bunch of different edge cases, and that's not really what we're testing for. Secondly, if you test against an admin role, you're simulating a situation where an attacker has achieved like one of the worst possible situations, which is they have full admin inside of your environment. Even in this worst case scenario, can your security controls prevent something like this? So this helps us validate as well. One more thing that I want to touch on the expected results section is when you're pushing out service control policies, it's an org-wide security policy. There's a chance you can break things. The other thing that this allows us to do is we can change the expected result to an allow and make sure that normal functions are still allowed. Going back to our example of a public-facing EC2 instance, we don't want public-facing EC2s, but we still want regular EC2s to be able to be spun up and spun down so our infrastructure can run. So we can make sure that when we push a control, we're not actively breaking prod. So changing the expected result to allow helps us validate that normal functions are continuing as expected. The other thing that we want to focus on that I alluded to, because I got a little bit ahead of myself, but the way that we handle these new test cases and API calls is honestly with like 5 lines of code. We want to make sure that whatever change we need to do is dynamically handled by the application code. So we have an arbitrary number of parameters, an arbitrary number of services, which can be defined in a test case. Doesn't matter how it gets called by the application code, it's going to dynamically instantiate the client, fetch the appropriate parameters, pass it into the AWS service, and then validate the output from there. So it's all handled dynamically at the application side. You just write your test case, things are good. There's some learnings and recommendations here that I'm going to skip over for the sake of time. But if you take one thing away, highly recommend the second bullet point, which is using a really permissive role for testing in a sandbox account. It's going to make your life a lot easier from an operation perspective. Okay, so we talked about the first preventive control, which is validating service control policies. And we highly recommend that you use these as much as you possibly can across your environment. But you're probably going to run into use cases where SCPs are not a suitable control. You're going to have to turn to resource policies. And the difference, again, being SCPs are centralized and resource policies are attached to individual resources. So we have a very similar infrastructure architecture for getting resource policies and validating them. What you're going to have is, again, a Lambda serverless, keep the operational load as low as possible. You're going to have an identity inside of every single account. You're going to fetch the resource policies just for data stores that you care about. Again, business critical data. It's probably not worth it doing for every data store that you have out there. And you're going to validate that the resource policy of that entity does not exceed the permissions of a baseline policy that you define. What this might look like in the example on the slide here is you can say you have a central data lake account, for example, that has a ton of data in an S3 bucket. And you say, hey, reading from this S3 bucket is allowed for a single identity, a special identity. Writing to this bucket is not allowed. So I don't care what happens. This is my security invariant. This is my security baseline. I don't want any changes outside of that. Now, IAM resource policies can be difficult to understand. They can be difficult to parse. If you're writing your own parser or you're pulling something from a library, you're kind of hoping that there's no bugs and it handles all edge cases. You don't have to do that anymore because AWS came out with something called Access Analyzer, which leverages formal reasoning under the hood. So it mathematically proves that access is less than or equal to some baseline policy that you're going to compare to. Example of what this might look like. On the left side is what we're going to call our baseline policy. There's actually a bug there in the get bucket call. It should be wildcarded, so I apologize for that. So we can define this resource policy here on the left side, which essentially says, hey, I'm going to say nothing outside of reading an object or getting a bucket's configuration is allowed, full stop. And then that kind of validates our control that we had in the previous diagram for saying this is our data lake bucket. You can only read, you can't write to it. And then the second thing we're going to do is we're going to allow a cross-account get object from a role called test role. And this is our resource policy that we want to have for all S3 buckets inside of this data lake account. Now, we can go in and validate the resource policies that are actually attached to these S3 buckets by pulling them with a Lambda, running them on Access Analyzer, and see if there's any difference. In this case, it's a get object call that we're comparing to. These permissions are less than or equal to our baseline. Things are good. Couple weeks down the road, somebody wants to make a change to the application. They modify resource configuration on an S3 bucket. Now there's a put object call in there which allows writes. Mathematically, AWS knows that these permissions exceed our baseline policy. Our check fails, and we know that there's drift in our security control that we need to come and fix. Some learnings and recommendations here as well. For the sake of time, we added a link to the AWS samples, which are super, super helpful examples to follow. Just be careful with the condition keys you're using. Make sure they're consistent across your IAM policies. It'll make your life a little bit easier. And now I'm going to hand it off to Georgios to talk about detective controls.
Thank you. So wait, are we done? Don't we have preventative controls? Are we validating those preventative controls? What else do we need, right? Unfortunately, we also need to have detections, right? Because even if we have all the preventative controls in the world, something might or will happen. We will have to detect an attack. We will have to respond and stop that attack. That's why we have detection and response team. Oh. This slide is messed up a little bit, but it's okay. I think actually also for this crowd, I didn't need to go in depth into this one. In this one, we had the AWS kill chain where I would go through where we would detect essentially an attack on AWS. But without the graphic, we can say that CloudTrail on AWS is very, very important. It's the logging service that we use on AWS to be able to detect any activity that happens on our cloud environment. Essentially, CloudTrail logs and monitors any API call that happens on AWS. And that is essentially almost everything aside from what happens within your resources, like an EC2 instance. So for example, we want to write a detection probably on CloudTrail to detect someone trying to elevate their privileges, potentially creating a new user or attaching a new policy to a user or a role, trying to do privilege escalation or even persistence in our environment. So AWS detections are very, very important. To do that, we need to build a detection pipeline. And this is a very, very simplified version of our detection pipeline and how probably everyone else should be looking like. We do have AWS CloudTrail. There is some piping before Elastic, namely CloudTrail drops the logs in an S3 bucket. You have an SQSQ that notifies Elastic, and then we pull those logs out in Elastic. Now, Elastic is our SIEM, or you can imagine whatever SIEM you're using, where you parse the logs, have ingest pipelines, enrich your logs, and eventually build your detection logic on top of it. This is where we're going to say if event that action equals create new user and attach these permissions, then create a detection. We want to know about it. Then what we do is we zip that out into our SOAR platform, which we use Tines. And in there, we do a lot of things like enrichment, aggregation of logs. We make sure that we provide as much information as we can on the SOC engineers that they're going to actually afterwards get a Jira ticket in our Jira queue, And sometimes for critical detections, we're going to get also a notification in our Slack for quicker response. So why I'm presenting this is because everything here might break, right? From the beginning to the end. Let's dive into that. So I might be a sad panda like this picture if my SIM fails, right? And that's after we got CloudTrail worked, we got our logs in, but our parser failed for some reason. Or we edited our ingest pipeline and that started dropping our CloudTrail. That might happen. Another very common maybe issue that you might see out there is, for example, with Elastic, if you are using in your detection logic a specific field in your query, and you define that as, let's say, a keyword field, and then after a month, after 6 months down the road, we go and onboard a new log source. And in that log source, we define that same field as a string. Then we're going to have a field conflict in Elastic, and actually Elastic is going to stop detecting our detection is going to break, and we're going to see failed on our detections, just because you have on a different log source that doesn't affect your detection logic. That field is a different type. We might also have configuration and permission issues that with changes, upgrades, stuff like that might fail in our SIEM. Then our SOAR or any automation that you're using, auto enrichment, might also break. When we are using a SOAR, to get detections from our SIEM and then ship them out to our ticketing system, what do we use? We use a ton of API calls, we use a ton of permissions. Something over there might break. We might have an authentication issue at some point. Our ticketing system API broke. We might even, knock on wood, have a SOAR outage and then all our automations break, right? In these cases, we're not going to have a detection, right? CloudTrail might fail. And I've never seen CloudTrail as a service fail, I think, unless someone else has seen it, please let me know. But possibly your log ingestion pipeline might break, right? When you're trying to pull the logs in, those, for some reason, might break. Again, might be permission issues, might be some lag, might be some service issues on AWS side, or S3. So again, there we're very, very sad, like this panda that's sitting on a cloud. And we just cry because we don't have detections and we cannot detect the activity that's happening on our environment. Last but not least, as David also mentioned, Lydia mentioned, and others, API on AWS always change. I've seen this multiple times that due to an upgrade and newer version, we might have a slight naming change. Sometimes it might be very slight, like adding an S at the end of the API call for some reason, or even having a completely different API call for the same activity. So also, when this happens, what is our result? We don't have a detection because we were trying to look for API call A, let's say that we're looking for create user, and then maybe 6 months down the road from today, this create user might be create users for some reason. And that actually happens often. So what do we need to do? We need to do the detection validation the same way that we have the preventative validation. So you can call this detection validation or detection testing. It is the same thing. And there are multiple ways of doing that. I think the manual testing, it's also something that someone would start with. It's going to be the most accurate, and it's something that is very, very easy for you to start with if you're not doing any validation of your detections. There are multiple tools, and I'm going to share some at the end. There are others previously shared a few, but it's a very easy way to start with. But it doesn't scale that. It's manual. You have to keep on doing it. It's not at a schedule, and it's only a point in time signal for you to say, oh, my detection is not working. Then we have static testing, and that is actually something that but some SIEM providers do have. I know, for example, Panther has a native feature that you can just add a document or a log in Panther and say, every hour, every 10 minutes, however you want to test it out. Just send this fake log into my SIEM, and that will go through the pipeline, and we can test if the detection is going to trigger. That has a few caveats. First of all, we're missing the last case that we saw before. If an API changes, it's a static test. You have to go and manually change that test. And also, even if it's not that the case, we are not testing the beginning phases of our detection pipeline. We're not testing the ingestion. We're not testing the CloudTrail service. We're not testing a lot of things. So what we ended up with doing, and I think it's the best value and very, very effective, is dynamic testing. Essentially, we do continuous testing. We continuously run the test instead of having the static test in the SIEM. We run the test on AWS, and we'll go through that, what that looks like. And this is very good, but does need some upfront work to build that automation unless you use another open source tool that there are a few out there. It needs some infrastructure, and then it needs some maintenance. Let's look what that looks like. So in our case, we saw before what our detection pipeline looks like, right? We have added a few things here. We have Terraform creating our resources, and that consists of an initial execute actions Lambda function, which essentially uses a YAML file, the same way that David built the preventative validation, that has our tests in there. And every test is associated with one detection that we have in our SIEM. So that continuously on a schedule runs those tests. And what happens when these run on AWS? We have CloudTrail. Now we do this in a sandbox account, and we have a few permissions there to be able to do the activities that we need without errors. And then we get it though in our organization CloudTrail. Then we go through our normal detection pipeline. It goes through the ingest pipelines. We test that. We make sure that it works. It goes through our enrichment in Elastic, all the parsing. It goes through our detection logic, then lands into Tines. And that's where the change happens comparing to our normal detection pipeline. We do have a filter there that looks for specific indicators that this is the activity of our test and says, okay, if that's the case, please do not alert our SOC engineers. We don't want to have our SOC engineers always saying, oh, another test happened, another test, another test. We don't want to burn them out. So we send that out to Amazon CloudWatch. And from there, we have alarms, CloudWatch alarms for each detection in an asynchronous way that they go on a schedule and check Amazon CloudWatch and say, did this test actually trigger the detection on a constant schedule? So we check again and again and again and make sure that it did trigger. When it doesn't trigger, that's where a CloudWatch alarm actually alarms us. And then it goes to an SNS topic where now a separate Lambda function, which is all of the AWS resources that you see here are just defined in a single page Terraform file. Our Lambda function on the latter end, which is the Slack notifier, looks for that SNS topic for new messages. And when one of our detection doesn't trigger, we're going to know that this detection did not go through our pipeline. So we need to go back and we need to go and identify where that happened. So this is how our tests look like. And I just had this as an example. We are only testing here the first action, which is attaching an administrator policy to an IAM user, which you should have been doing, either using IAM users or attaching admin policies, of course. And then essentially how our Lambda works is that it goes through here, through the test ID and the name, and it looks how many actions, and also parameters. We can add parameters and actions there for different API calls. So in this case, we are only having a detection for the attached user policy, which is what we want to see that gets triggered all the time, and we go through the pipeline and make sure that it goes through, no issues there, our detection works. But then I just added as an example to show that we can have multiple actions that course, afterwards, when I attach the policy, I also want to detach the policy just for the sake of not leaving an IAM user on our sandbox environment with the admin policy. So there are a lot of open source options out there for you. And Lydia touched a little bit on that. There's a lot of good work happening from Datadog. So Datadog has a Stratus Red team and lately the threat test. It is, I believe it's a CLI and a Go library that you can utilize. But I think that out of the box, they integrate directly with Datadog as the SIEM. Then you have Atomic Red team by Red Canary, which is just atomic tests that you can run. And then we have Leonidas, similar, I think, to Stratus Red team. And then last but not least, and this is actually the tool that I would recommend anyone who's not doing any type of validation in AWS to start with static testing. You can start with Pacu by Rhino Security. They have a ton out-of-the-box tests for privilege escalation, multiple different paths for privilege escalation. They have very good documentation. So if you want to start doing validation manually, you can start from there and then either utilize an open source option or, like we did, build your own in-house solution, which is, I believe, that you can do with very, very low effort. Just what we use is Python, Terraform, and utilizing the AWS services. And that's it.